All right, guys, we got 4 more problems left to go. Here we go. You want to make an open box that has no lid with a square bottom, a height of 5 inches, and a volume of 1,125 cubic inches. To do this, you take a square piece of cardboard, cut 5 inches long, cut 5-inch long squares from each corner, and you fold up the edges. What should the dimensions of the cardboard be before you cut it? Okay, so I just want to do just a little demonstration here. You start out, so I kind of already cut it because I didn't have scissors, but here is your square. Okay, we want to know this dimension and this dimension, which they're the same because they're a square, right? All right, then what we do is we know these are 5 inches. We know they're 5 inches. They're telling us, if you read it, it says you cut, let's see, what does it say? You want to make an open box with a square bottom, a height of 5 inches, and a, no, yeah, oh, I see, and a height of 5 inches, and a volume of 1,125 cubic inches. Okay, they kind of read this weird, though. To do this, you take a square piece of cardboard, cut 5-inch long squares. There it is, 5-inch long squares for each corner, and fold up the edges. Okay, so we're cutting out 5-inch squares, right? Now, why do they also mention that the height? So I cut out these squares, chop, 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 gone, chop, 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 gone, cut this out, okay? But notice they also say a height of 5 inches. Well, look at that 5. Now what they say is you fold this up, and here is your very generic box with no lid. Okay, and notice, so there is my box with no lid. Notice that 5 that I cut, what does that 5 become? This might be the best place to see it. That 5 becomes, I don't know if you guys can see it, the 5 becomes the height of the box. That 5 that I cut out becomes now the height. Notice that all those 5, this is kind of like, remember when we were doing our cans project and we were supposed to make that template? See how this is 5 and this is 5, but see when you fold it, they actually come together. Okay. A web, right? Is that what we called it, a web? So that becomes the height. Okay. But remember, we're trying to, and we'll draw a picture in a minute, we're trying to find the length of this whole thing. Now, how would we find the length? And then we'll go to the picture. How would we find the length of this whole thing? We're going to call this whole thing X. All right, so let's go. I think that'll be okay. Let's go to our paper. Let's redraw that. Let's redraw this. So we've got our whole thing here. This is our square, and then we're cutting out these 5 by 5s. Okay, but we want to know this whole distance, so we're going to call that X. Okay, we're going to call that X. This box, maybe we might need this box again. This box is volume. How do we find the volume of a box? Length times width times height. So I think we talked about if this is 5 and 5, we know that the height is 5. Okay, and we actually know the volume, right? The volume is the 1,125. So we're actually going to put a 1,125 in there for volume. We need the length and the width. So this piece here, right? I can come back here. That red line is this red line right here. Okay. We need to know the distance of that red line. Well, if the whole thing is X, I take off 5 from this part, I take off 5 from this part. So the whole thing is X, I'm taking off 5 and 5, then I have my red line. So this is X minus 10. Okay, and this is actually the same thing. This is this guy here, is this line here, My whole thing is x, but I took off 5 here, and I took off 5 here. So if this whole thing is x, because it's a square, so this is an x as well. I'm taking off 5, and I'm taking off 5. This is now x minus 10. So my length and my width, and then my height is 5. So let's rewrite it. My length is x minus 10. My width is x minus 10. And then I have this height of 5. Okay. Now there's a couple ways to do this. The one thing that I see is, why don't we take this 5, because we're multiplying it, why don't we divide, because this is a 5, it would go in there very nicely, so why don't we divide both sides by 5? We can do that whenever we want. Now would actually be a good time. So this is 225, okay? So these cancel, I still have x minus 10 times x minus 10, and what do I have to do? I have to FOIL. So that first gives me x squared, outer gives me negative 10x, inner gives me negative 10x, and last gives me 100. Okay, it does not equal 0, so I got to think about that piece. I can collect like terms here, x squared minus 20x plus 100. Okay, but it equals not 0, but 225. So the first thing I want to do is subtract 225. Now I have my 0. Now I can think about, let's see, 100 minus, well, that's not too bad. 100 minus 225 is negative 125. Now I can either do, now that I have 0, I can either do quadratic formula or factor. I think this factors, this is not too bad, because 100 is 25 times 4, right? 125 is 25 times 5, right? How many quarters do you have here? You had 4 to make 100, and then another extra. So 25 times 5. And I need to make one of them negative, and oops, this guy, shoot, this guy here should have, this guy right here, this guy should have an x. That looks better. All right, so I need a negative 20. So if I make this negative, I would get negative 125 when I multiply, and I would get negative 20 when I add. Okay. Again, here, if you're like, I would just rather go to the quadratic formula, go for it. If you want to try to factor, this one does factor. So it factors to x minus 25 and x plus 5. Okay, so let's check that. That multiplies to be negative, make sure we can see this, negative 125, but adds to be negative 20. Okay, beautiful. Okay, so those were the numbers I chose, but now what does that actually mean x is? X is 25 or negative 5? Negative just doesn't fit our situation. It fits my equation, but it doesn't fit my situation, so that guy's gone. So x has to be 25. Okay. So my what should the dimensions of the cardboard be before I cut it? X by x. So 25 inches by 25 inches. Okay. All right. Now, where's our next one? Okay. Oh, yep. Okay. All right. These last three are a little crazy. All right. Here we go. All right, but once you get the picture, I think that's going to help a lot. So obviously doing these 3 examples, they're all very similar. Each one's though just slightly different. Okay, Tom is building some dog runs at his house. He has 4 dogs, so he wants a dog run for each one. Dog run is kind of like one right next to another, just where it's usually a little bit longer and thinner, just enough so that they can run, but just a little bit. One side will be his house. So he needs fencing for the dividers and the other 3 sides. So here is his house. Okay, and I'm going to kind of make a jagged just because there is not going to be fencing there. Okay, but then he's going to put fencing, fencing, fencing. Okay, and he wants to separate these dog runs. 4 dog runs, so that actually means we have 3 lines, right? 1, 2, 3. Okay, 3 lines, is actually going to give us these 4 dog runs. Okay. This line will be fencing. Okay. And these are all going to be the same length. So all of these are X. Okay. This is different. Okay. And there's absolutely no fencing here. We don't need a number for here because this is the house. Okay. One side will be his house, so he needs fencing for the dividers and the other 3 sides. 1, 2, 3. Okay. He wants a total area of all 4 runs to be 250 square feet. Okay. He has 200 feet of fencing. What should the outer dimensions be? Okay. So we don't know what this line is. This line is y, okay, from all the way from here to here. Now, let's talk about area. Don't worry about all these, okay? How do I find the area of this? How would I find the area of that? Don't worry about these lines. My area would be equal to x times y. Don't worry about the inner stuff, right? This side is x, this side is y, area is x times y. I know my area is 250. Okay. The problem is I don't want 2 variables. Okay, so I've got x and I've got y, and that's an issue. I know it's going to be a little messy, but we don't want 2 variables. That's even worse. So I'm going to solve this for y. So I'm going to divide both sides by x. Divide both sides by x. That would be helpful. So 250 divided by x is equal to y. And so instead of using y, even though it's kind of messy, I'm going to do 250 over x. Because now everything is in terms of x. How many variables do I have? I only have 1 variable. Okay. Now we use this piece. He has 200 feet of fencing. So fencing is equal to, he's going to put fencing here, 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 and here. It's just a length. So 1, 2, 3, 4, 5. So I'm going to do 5x plus, and then I also have to add this length. This length is y, or 250 over x. I'm just adding this up. This is just a total, because fencing is a length. So I want this, plus this, plus this, plus this, plus this, which is 5x, plus this is just a little bit different, so I have to add it separately, 250 over x. Okay, and how much fencing? 200. Now, this looks crazy, but I've got 1 equation with 1 variable. The way to solve this is to multiply everything. Notice I'm including the 200. I multiply everything by this guy here, this x, everything. So this is now 200x. Now it goes here, 5x squared. Now what happens when it goes here? It goes on top, but the x's cancel. So plus 250. So very important that I multiply the left side and the both on the right by x. I multiplied everything by the same thing. That's okay. All right, so let's see. Oh, hang on a second. Shoot, I didn't want to mess this up. This is, oh shoot. You guys have different numbers. Shoot. That's weird. And this, okay, this one got changed. I'm not sure how this is going to work out. This might work out okay. I think it's just going to be, hang on. All right. You guys have, when you're looking at your note sheet, you guys have this number to be 205. Huh, I wonder what happened there. Shoot, and this number was 65. I'm not sure what happened there. Okay, so we can we fix it? Sure, why not? Okay, so this number here should be 205. That number should be 205. We can fix this, guys. So that number's 205, just so it matches your, so we're okay. This guy's going to be 205. Okay. And then this was only supposed to be 65 feet of fencing. Interesting. Okay, so this is only supposed to be 65. Okay, so, and you guys shouldn't have to change these. These should be your actual numbers. All right, so just where I had 250, I put in 205. And where I had 200, I put in 65. All right, we'll do another one down here. Let me check the numbers. This one is right, so I do not know what happened here. All right, so okay, so let's rewrite this. We got 65x equals 5x squared plus 205. Okay, so we just changed where 250 was, we changed it to 205, and where 200 was, we changed it to 65. So that's okay, we can do that. All right, so now everything to one side. Everything to one side. So now we've got 0 equals 5x squared minus, notice this one I'm going to put in the middle, 65x plus 205. Okay. Okay, so now either quadratic formula or factor. Either way, I'm going to take out a 5. So x squared minus, so what's 65 divided by 5? 65 divided by 5 is 13. And then 205 divided by 5 is 41. Okay. I think that we still have to do quadratic formula. Okay, we still have to do quadratic formula. So x equals the opposite of b, so that makes it 13, plus or minus the square root of, make sure you do negative 13, but you're squaring the whole thing, including the negative, minus 4 times a, which is a 1, times c, which is a 41. Okay, all over 2 times a, but a is 1. Remember, this number here is a, this number here is b, this number here is c, and I don't need the 5 anymore. Okay, so now with our changed numbers here, right? So now we get x equals, we get 13, plus or minus the square root all over 2. All right, let's do this square root. Remember, we need the negative must be in the parentheses. Minus 4 times 1 times 41. Okay, and that gives us 5. Okay, so now we're going to do 13 plus the square root of 5 divided by 2, and we're going to do 13 minus the square root of 5 divided by 2. Okay, so 13 plus the square root of 5, I hit enter, and then divided by 2, oops, that was an enter, divided by 2, that should give me something like 7.6, okay, and then 13 minus the square root of 5 divided by 2. That should give me 5.4. Ah, interesting. I actually mentioned that in the other one. Notice both of these are positive. So both of these will work. Okay. 7.6 is my x. And this is, now let's correct this. This is 205. This would be 205 divided by 7.6. Okay. And 205 divided by my other number, 5.4. Okay, so 205 divided by 7.6 is, it rounds to basically 30, or I'm sorry, not 30, 27. And then this one, 205 divided by 5.4 takes us to 38. Okay, so I got two sets of answers here. Maybe I'll write it. Can you see it up here? 7.6, okay, by 27. Or it could be 5.4. 5.4 is this distance, And then if I use the 205, which should be in yours, I'll make sure that that's in yours, by 38. Okay, so that you actually have two sets of answers for. Okay, now let's try it again. This one's basically identical. Well, there's it's actually maybe a little bit harder, and there's bigger numbers, so let's go at it. Hilltop School is building new tennis courts. It will be 2 courts together with fencing all around and fencing between the 2 courts for separation. The total area that both courts together will use is 14,500, and that's what you guys should have as well. They are going to use 650 feet of fencing. What will be the outer dimensions of the total court? No. What will be the outer dimensions of the total court area? This should not be there either. Okay. Oh boy. Okay. What will be the outer dimensions of the total court area? Maybe I should say both courts together. This one said what? This one said what should the dimensions be? This one we actually want. Oh no, same thing. Yeah. What will be the outer dimensions? Okay. So we have one court and then another court. And there is going to be fencing here. There'll be fencing here. There'll be fencing here and on each side. They're going to actually put fencing between the 2 courts. Okay, so we're going to have X, X, and X. Okay. Area for both, so this is different. This here is Y. Okay. Area is equal to, now the area of both, the area of this whole thing. Okay. Also, actually, maybe we should mention this now. This is how this one is different. This, we're going to have fencing over here as well. This is going to have fencing. Here there was a house, but here this is going to have fencing all the way around it and down the middle. Okay, but just to find the area of this, you're going to do X times Y. Area is, how we do it? Area is, what is the area? Area is 14,500. X, Y. But we don't want X and Y. So we're going to divide both sides by X. And we're going to do 14,500 divided by X is going to replace Y. Okay, so instead of Y, we're going to do 14,500 over X. Okay, that number goes from here to here. Okay. All right, fencing. Where am I going to put fencing? I'm going to put fencing here. I'm going to put fencing here. And I'm going to put fencing here. So that's 3X plus, I'm going to put fencing here, 14,500 over X. And I'm going to put fencing here, which is a Y, which is another 14,500 divided by X. Okay. And how much fencing am I going to use? 650 feet. Okay, we could add these. If it looks weird, let's do our next step, and I think all those numbers should match, right? Multiply everything by X. Same thing that we did up here, multiply everything by X once we got our numbers corrected. All right, so this is 650X. It goes here. 3X squared. X times X gives you X squared. The X goes here. This, I guess we could even write it. When it goes here, it goes there. When it goes here, we got X times X, which is X squared. When it goes here, it's right there, and those cancel. So I just have 14,500. And then it goes here in the numerator, and those cancel. So I have another 14,500. Okay. All right, that looks good. Okay, so we've got a quadratic. We've got a quadratic. So we've got 650 equals 3x squared plus, we might as well add those together, right? That gives us 29,000. Okay. Now, notice this has an x. So when I move it to the other side, I still need one side equal to 0. And I did it here, but I want to put it right here in the middle. Because it has the x, I want it in the middle. That's fairly important. Because it has the x, you want it in the middle. So it's going to be 3x squared minus 650x plus 29,000. Okay. Okay. So now, I don't think I can take a 3 out of this or this. So I'm just going to have to go at it. X equals opposite of b, so 650 plus or minus the square root of, technically it's negative, but I have to square everything, minus 4 times a times c. So I'm just going to have to deal with these big numbers, but I'm going to use my calculator anyways. Now be careful here. It's over 2 times a, which is a 3. Okay, so we got 650 plus or minus. I'm going to take that down to a square root, and it's going to be over, notice it's going to be over 6. Okay, so let's do this guy, parenthesis, negative 650 squared minus 4 times 3 times 29,000. And that should give me 74,500. Okay, I'm running out of room. Grab paper. All right, slide this up. How are we doing? We can see, we just need that problem here. All right, so x equals, grab your calculator. Let's do 650 plus the square root of 74,500. I'm going to hit enter, divided by 6. And that gives me 153.8. And then I do it again. 650 minus the square root of 74,500. Enter, and then divide by 6. Remember, this one is 6. And I get 62.8. Okay. Now, these are not my two dimensions. These are two different values that x can be. Okay, so x is 153.8 by, and I have to go find y. Or x can be 62.8 by, and I had to go find y. So y is 14,500 divided by my x. Okay, y is 14,500, taking it right from here, or even here, divided by my x, which was 62.8. Okay, so the best answer then is 153.8 by, let's see, did I want the dimensions? Yeah, by, okay, so 14,500 divided by 153.8 gives me 94.3. And then this one, or 62.8 by 14,500 divided by 62.8. Okay, by 230.2. Now, one of these probably can be tossed. I don't think this would fit a tennis court, but technically it is an option that fits this square footage and the length of 50 feet. But I have a feeling this guy could be tossed because well, I'd have to think about it, but I don't, maybe that might actually work. I'd have to check the dimensions of a tennis court, but it's at least an option. Okay, it fits both of those situations. The third situation is we'd have to go back and look at the dimensions of a tennis court. Okay, so notice that my answer for these two numbers is not x and y. These are two different x values. And then you have to go back and find a y value that matches each of those. Okay. All right, let's do last one. Here we go, guys. Last one for the semester. Well, I guess you have review, but last new thing. This one's kind of neat too. A farmer. Let me check to make sure our numbers are the same. Okay. Yes. I don't know what happened in that one. Okay. A farmer wants to enclose a rectangular area and divide it into 4 sections. If he uses 1,000 feet of fencing, what is the maximum area the rectangle can be? Okay. So, and this, now, this is important, so make sure that you watch, because a lot of kids, and I understand, they did this, divided it like this. We're talking about 4 sections like this. Okay, and I get it, it's just, maybe not clear enough. They might give you a picture on the homework. I have a feeling they will. So, okay, so a farmer wants to close in a rectangular area divided into 4 sections. Okay, if he uses 1,000 feet of fencing, what is the maximum area the rectangle can be? So we're going to call this X, but if this distance is X, so is each of these. Okay, and we're going to call this Y. Okay, but this time it's not area. We don't know anything about area. This time we start out with fencing. Fencing, where would I put, and I'm actually going to put fencing here as well. So this is going to be Y as well. So I'm going to do 1, 2, 3, 4, 5. So 5x plus Y and Y, which would be 2y. And the fencing is 1,000 feet. Okay, so how do I solve this for y? Because I don't want x and y. That's no good. So I want to solve this for y, so I'm going to subtract 5x. I have 1,000 minus 5x equals 2y. And then I'm going to divide each of these by 2. You can do the whole thing, or you can do each one. So this one, I'm just going to do each one. That way we'll kind of have numbers, get rid of the fractions. So that is what? 500 minus 2.5x equals y. Okay, so now that replaces the y. So instead of the y, I'm going to use 500 plus minus 2.5x. Okay, so this is going to be 500 minus 2.5x. That way, I don't have 2 variables. I only have 1 variable. Okay, so now area equals x times y. Area equals x times y. X is going to stay. Y is going to become my 500 minus 2.5x. I don't have a number for a. I don't have a number for a. So a equals, I am going to distribute 500x minus 2.5, x times x gives me x squared. I want my x squared first. So make sure you take the negative with, negative 2.5x squared. My 500 is positive. My 500 is positive, so plus 500x. So I just switch those two, but notice my 500 is positive, my 2.5 is negative. But what am I doing all this for? Because now I'm back to 2 variables. Okay, over here, as soon as I had variables, I plugged it in. I only want 1 variable. Here's the cool thing about this. We're dealing with a parabola. It says maximum. What are you supposed to associate with the word maximum? Vertex. Maximum goes with vertex. How do you find the x-coordinate of the vertex? Vertex, x-coordinate. Vertex, the x-coordinate of the vertex, negative b over 2a. X-coordinate of the vertex, negative b over 2a. This is a, this is b, and my c would actually be 0. Negative b, so negative 500 over 2 times a, and a is negative 2.5. Okay. So now we type that in. What does that give us? 2 times negative 2.5 gives us negative 5. So x is 100. That's it. Let's see. What is the maximum area the rectangle will be? The maximum area. So if I want the area, I have to do x times y. X times y. So if I want the area, we're going to go back one last time. Here we go, guys. A equals x times y. But what is y? Y was 500 minus 2.5x. Okay. And then x is 100. So 100 times 500 minus 2.5, we'll do it this way, times 100. Okay. So we do all right, so if we do 2.5 times 100, we get 250. So let's see, should we write this? We can write this. 500 minus this would give us 250. 500 minus 250 gives us 250. Right, we can do 500 minus 250. That gives us 250 times 100. 25,000 is our max, can you guys see, is our max area. Maximum was vertex, the x coordinate of the vertex, negative b over 2a. Then once I found that, then they wanted me to find the area because this is the max. So I plug it in for x times y, but we know that y can be this guy. So I have to do x times my new y, because that's nice because it called for x, so I can just plug that in, work it out. All right, guys. Last WebAssign. So check that out on WebAssign. That's your last homework, and then I'll give you a review, and then we'll take the test.